So on this page is some basic trig review. Hopefully most of this looks familiar and I don't have to go through it. It's a reminder to all of you of what our trig functions are and where they came from. I do want to remind you that theta is always in radian measure. And as you look at the two diagrams that I have in the upper right hand corner, this one over here, the radius is just some general r. If I go over in a horizontal distance of x and a vertical distance of y to get to the point xy, my hypotenuse is r. And in this one, the only difference is I set r equal to 1 to make it the unit circle. But all of those trig ratios should look familiar to you. And we should think of things in terms of radians. So if I wanted to figure out if theta was 5 pi over 6, which quadrant that fell in, I would think in terms of my radian measure. This is 0, this is pi over 2, this is pi, this is 3 pi over 2. And since I'm thinking in terms of something over 6, I want to think of all my angles in terms of over 6. So this one is really 3 pi over 6. This one is really 6 pi over 6. This one is really 9 pi over 6. And this one is really 12 pi over 6. So now when I try to figure out exactly where 5 pi over 6 falls, I see that it is in the second quadrant. It is shy from 6 pi over 6 by a pi over 6 angle. And now I would be able to find any of the trig functions with pi over 6. So let's recall what the sides opposite and adjacent and hypotenuse are for these triangles. So if I have pi over 6, the side opposite that is 1, this hypotenuse is 2, and the side adjacent is square root of 3. This is in the second quadrant, so this happens to be negative. So in this case, the sine is opposite over hypotenuse, or y over r. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent, which we would also rationalize by multiplying top and bottom by the square root of 3 and get the square root of 3, negative square root of 3 over 3. Okay, one last thing that I want to review are our reference triangles. If theta is a pi over 6 angle, then the side opposite from that is 1, the hypotenuse is 2, the adjacent side is the square root of 3. And remember, if you're doing this in a unit circle, since the hypotenuse in a unit circle is 1, each of those would be simplified. The hypotenuse would be 2 over 2, which equals 1. The opposite side would be 1 over 2. The adjacent side would be square root of 3 over 2. If this is a 45 degree or a pi over 4 angle, the two adjacent and opposite sides are congruent and the hypotenuse is square root of 2. Again, in the unit circle, that hypotenuse would be square root of 2 over 2, which is 1, which means the other sides would be 1 over square root of 2 and 1 over square root of 2. And then, of course, we should be able to figure out the pi over 3 angle in a similar fashion. To remember on the unit circle, this ordered pair is the point 1, 0. That represents the cosine and the sine at 0 radians. This ordered pair is 0, 1, which represents the cosine and the sine at pi over 2 radians. This ordered pair is negative 1, 0, which represents the cosine